Hello ladies and gentlemen, welcome to another stats lesson. This lesson is about choosing our sample size. In this case I decided that it's probably easiest to learn this just by jumping straight into an example. So I thought I'd give you a nice little example about video games. If you ever happen to play online video games, you've probably heard the term lag. For those that haven't heard what lag is, it's basically how long the commands that you're entering on your computer take to get to their server. Well, when they reach their server, then they actually get to execute the command. So the issue here isn't so much how long the lag is as the fact that if somebody else happens to have less lag than you, it gives them an advantage since their commands are executing before yours are, even if you entered them at the exact same time. So let's get down to the stats problem. For a particular game, players want to know the usual lag they experience with a 95% confidence interval and a margin of error of 30 milliseconds. From a few rough observations, they think the standard of deviation is about 60 milliseconds. That's just a guess, obviously. How many times do you think that this lag should be sampled to actually determine this properties? Well, our formula in this case is, a bunch of looking symbols, ME and T star and S and the square root of N and what? As you know, I like to define variables when I start using formulas. So let's find out what some of these things are. ME represents our margin of error. The T star N minus 1 on the bottom subscript and all of that, well, that's the T critical value for the degrees of freedom that we have. Degrees of freedom being represented by the N minus 1. S in this case is the sample deviation. Sometimes we'll use S with a little subscript of X for that. And N is going to be the number of samples. That's kind of the usual. In this case, we're actually looking for N, so we really don't know what it is yet. And that in and of itself is its own problem, but we also can't find the T critical with N minus 1 since it also relies on N. So what are we going to do about this? Well, a neat little trick for this is instead we're going to use the Z critical or the Z star from the 68, 95, 99 rule. In this case, for a 95% confidence interval, it's just 2. So write the formula down and actually start plugging in your numbers. From the problem, we could tell that ME is 30. We're going to use 2 for the T star. S, we were guessing that around 60 milliseconds. And of course, we're looking for N. So plugging in the numbers, it looks a little bit more like this. And now all we have to do is solve for N. Well, 2 times 60 is just 120, so that's an easy simplification. And then we need to get that root N off of the bottom, so we multiply both sides by it, and you end up with 30 times root N equals 120. That means root N is 120 divided by 3, or 4. Well, if the square root of N is 4, that means N is actually 16 when you square both sides. 16? That's a kind of small sample size. So maybe we ought to do a little bit more calculations just to make sure. But this time what we're going to do is we're going to actually try to calculate the T critical using N equals 16 for the degrees of freedom in the original formula. Well, actually N equals 16 for the sample size, and then we're going to be able to find the degrees of freedom in the original formula. So back to the formula again, and we're going to plug in the same numbers except where the T star is. This time we're going to use 2.1314. What? 2.1314? Where'd that come from? Glad you asked. Let me pull up the calculator here just a second, and I'll show you where it comes from. Alright, I've pulled my graphing calculator up, and what I'm going to do is I'm just going to show you how to calculate this. The first thing you need to do is press the second key. Then you want the VARS button, which has distributions above it. You notice on the list that INVT, or inverse T, is number 4. So I'm going to select choice number 4. It'll give you a nice little menu that says where the area is in the DF, which is the degrees of freedom. So if you've paid attention to the past videos and things, you know that for a 95% confidence interval, what you want is 97.5 in this case. So you're going to enter 0.975. Enter that, and then the degrees of freedom is going to be 16 minus 1 for this, because we chose 16 for N. So that's 1, 5. At which point you can enter that and then just choose paste. It'll actually put that on your main screen, at which point when you enter one more time, it'll actually calculate it for you. and there's the 2.1314 that I used in my calculation. And now that I've got that calculator out of my way, we can continue with this calculation like we were doing. 2.1314 times 60 is about 127.884. Doing the same exact math that we were doing a moment ago, trying to solve for n. Again, 30 square roots of n is going to equal the number that was on top. So the square root of n is going to be that number divided by 30, or about 4.2628 in this case. That's not a whole lot off of the 4 that we had originally. But this time n does come up to be, about 18.17. Well, since we're supposed to guarantee that it's within our margin of error and that it's no larger than the desired, what we're going to actually use is 19 for n. Still a small number. But even though it's pretty small, we're also reasonably sure that it will tell us our desired result. So that is just a small example that gives you an idea of how to actually choose or calculate the sample size when you don't know how many people that you should actually sample, or in this case, exactly how many measurements you should take on the lag. So when you're choosing a sample size, there's something for you to follow. And that's probably enough for this stats lesson, so have a great day.